Hello and welcome back in the second part of our code along to create a token deployment platform. As we described this in the first video, it will be a platform where users can connect their wallet and deploy any token they wanted. It will be multi-chain, it will have a dashboard, and as you can see, I did not create it beforehand, and I'm actually I'm creating it as we go along, so you can go with me through the thought process and how I think ahead and how I'm trying to create it, so you would understand better how to actually create real life projects, because most of these code alongs or video tutorials, they are like prepared and scripted, so the guy already done all that and then he's just on autopilot, if we may, right? So they just like going through it, but they already stumbled across the challenges, and they already figured out how to solve these challenges without like off camera. So when they are recording, there is no challenges and you think that it's going smooth, but that's not how things work in real life, right? You will always find issues, you will forget stuff, and I think this is a better approach or like to learning. And the other thing is, if you think that you can learn programming just by reading or not doing, it doesn't work that way. You have to actually do it, and you have to try to create it yourself, and you have to actually stumble or like hit those roadblocks and these challenges that you don't know the solution, and you need to go search for them, and you need to go read the docs and other things. That's how you actually learn, because programming is not about creating stuff, it's more about solving problems. So the second you start programming or creating a new project, it's like you're solving problem after problem after problem until you solved all your problems and your product is ready now. Okay. So in the second part, we are going to create the mint burn token. Okay. This is the repo as we left it last time. I did not touch it. I did not add anything. I did not put any work into it. So, and maybe you're wondering, or like I've been asked, like I put too much time into this, right? I put like 2 hours creating this, making tests for it. And to me, it is worth it. Why is it worth it? I now have a building block, like a platform for ERC20 token that I can trust, that I created, that I know it's efficient, that I know that it works. It has all the tests around it. So now if I want to extend functionality, I only have to inherit from the simple ERC20 token and create my new token with new capabilities, and that is what we are going to do here. So when we start creating the Mintable token, we are going to use inheritance to actually inherit the simple ERC20 token and inherit all the functionalities that comes with it and extend on it, like add the minting and the burning. Okay. So last time when we ended here, I thought about something. And I realized that we had one test that was passing, but it shouldn't. Because my mint function here does not actually add anything to the total supply, right? And it just came to my head, like right after I ended the video, it came to my head and I wanted to fix it immediately, but then I thought, no, I will wait to the next video and I'll fix it. So we will understand. So these things happen. You just need to like, well, we would have stumbled into the issue later when I'm not going to fix it. We're going to go with we are going to actually implement it as it is. And when we hit, this is the test that is not failing, because we're expecting it to be 0. Well, in reality, it should be the initial supply, right? So that's the issue here. So we're doing the wrong test. And I want to show it now because later we're going to stumble to it, but I want to show you like later how we will stumble into this issue and why the tests are very important. And even if we messed up here, as we go and we create more tests, we will stumble, or like we will find the issues that we raised, that we created in our code or in our implementation. Okay, so I'm going to leave it until we actually reach it. Okay, so I'm going to go ahead and create a new contract here. I'm going to call it Mintable ERC20.sol, right? So as we said before, same as before, same everything. So we need to put the license line and the pragma line. Okay. So the pragma, as I explained before, the pragma is the version of Solidity we are using to compile our file, and the license identifier is what license is this code under. Okay. And I explained also why I used the BUSL library last in the first part. If you didn't watch that part, I really suggest you go there. So now I'm going to create a contract Mintable ERC20. Okay, and I'm going to disable GitHub Copilot for now. So Mintable ERC20, let me just Mintable ERC20 token. I'm not going to add token, and this is the Mintable ERC20 token. Okay, this is a contract. And now to inherit another contract in Solidity, you first need to import it, right? And to import it, it's kind of similar to JavaScript imports. ES6 import, so you import a file. So in this case, I'm going to import the simple ERC20 token, and by adding this, it says that the file is not found, but I'm pretty sure it is there, the extension here. Okay, so when you import it, now you have access to all the public members of this. So in here, there is the simple ERC20, now we have access to it. And to inherit another contract, all we have to do is add the keyword is, and then followed by the name of the contract we wanna, and in this case, it's the simple ERC20 token, right? Now we imported it, and it's going to complain about stuff, right? And in this case, it's going to be saying it should be marked as abstract. And the reason it's saying it should be marked as abstract is because the ERC20 token constructor is actually has some immutable values that needs to be initialized on the first deployment, right? So we need to actually do that. Go ahead and actually call the constructor. So we're going to create our own constructor for this specific contract here, right? All right. So we create the constructor for this contract, and we need to actually call the constructor of the simple ERC20 token. And to do so, after our constructor, we call ERC20 simple ERC20 token here, and then we give it the arguments. Okay. Now we're going to take the arguments in our constructor and pass them along. Okay. So same constructor arguments as this one. We're going to take them in here. Okay. So the first thing we're going to take is string memory, and this is the name, and then we're going to take a string memory symbol. And we're going to take a uint 8 decimals, and we're going to take a uint 256 initial supply. All right, and let's just go ahead and format this so it doesn't get out of the screen. Okay. Now all we have to do is pass them along, right? So we're going to pass the name, name, and we're going to pass the symbol, and we're going to pass the decimals, and we're going to pass the initial supply. Okay. So in this case, we are actually creating all our stuff. I'm going to go ahead and call yarn format. So Prettier will format it for me. I don't have to format it myself. Now it does not complain. It does not tell you it needs to be abstract. If you didn't wanna create the constructor here because you're not going to instantiate this specific contract and you're just using it as an intermediate abstract contract that someone else, another contract, is going to inherit, all you have to do is add the abstract keyword here, and then this contract will become abstract, which means it does not need a constructor. Okay. Now what do we need? We want our ERC20 to be mintable, right? So we want to have a mint function. Okay. So let's go ahead and create the function. We call it function mint, right? And then it takes an address to where do we mint, and uint256 value or amount. Let's call it amount, and it's external. And what it does is it calls the the internal function of mint, the one that we already defined in the simple ERC20 token, and it should just mint an amount to the to address. Okay. So the first issue we can see here is if we set it this way, what it means is that anyone can call this function and mint tokens to his wallet, right? Or to anyone. And that's not what we want. We want to have a certain addresses or certain accounts that can mint, but not everybody can mint, right? So what I'm going to do is I'm going to create a mapping, right? A mapping that I'm going to call that is a mapping of addresses into booleans, okay? And we're going to call it minters, okay? And we are going to create a function to set a minter, and we're going to create a function to retrieve minters. And while we are at it, I'm going to make this mapping private because I don't want the inheritors to be able to touch the minters or add a minter without going through the proper channels. Okay. And now with these minters, we are going to create a function that adds a minter. Okay. So let's call it a function. And we are going to call it add minter. And it takes an address. Actually, let's make this better, because if we do add minter, we will have to create another function that is remove minter. I think set minter, let's call it set is minter here, to specify that we are actually taking a boolean, and then minter, and the second argument is a boolean that is minter, and we call it external. And what it does is it will do minters as minter. I'm going to add an underscore afterwards here, just to, and we're going to say is minter. So basically what this function does, it can add or remove a minter, okay? Now another issue that we can see right off the bat is this function can be called by anyone, right? So what the hell? right? So what we are going to do right now is we are going to create a different contract that handles the ownable standard, okay? And an ownable standard will be, let's see, let's go here and let's do ownable standard Ethereum, and we will go to the proposal, and we can see here this is the contract ownership standard, and it gives you specifically what you need to have. So this is the interface, and this is another interface for supports interface, right? But we're not going to implement that one. We are going to do the interface here. So let's create a new contract. Let's call it ownable.solidity. And we are going to copy the pragma and the license. I don't want to type it. And then here we're going to use contract. We call it ownable. And we are going to look back into the interface. And this is the interface. So we need an event, right? I'm going to copy it from here. So the first thing that we need is an event. Actually, let's create a new folder. Let's call it interfaces, right? And then we are going to copy this interface. New file. I'm going to add the I at the start here to indicate that this is an interface, not the actual implementation. .sol, right? And then same as before. And the way you define an interface in Solidity is to use the interface keyword, interface, and then followed by the name of the interface. In this case, ERC20 And then what I'm going to do is I'm going to just copy the names of these functions that they needed, that they defined it for us here, and then we are going to implement it. Okay. All right. Now I'm going to copy the pragma and the license. And after this, we are going to go back to our ownable, and we are going to import the interface. Same way as before, import, and then import interfaces, and then the ERC.solidity.sol. Now we imported it, and then as before, same, when we inherit or when we implement an interface, we use the same keyword is and then the name of the interface. All right. Now it's going to complain here and should be marked as abstract. Why should it be marked as abstract? Because the actual functions here are not implemented, and we need to actually implement them. And if we don't, we mark it as abstract. So the one who inherits Ownable will have to implement them. But we don't want that either. So this event is already defined here, so I'm going to remove it. Then I'm going to create a constructor here. Constructor that takes no arguments. Okay. Now we need to save, we need a place where to save the owner, right? And I'm going to create a state variable address that is private, and I'm going to call it owner, right? And I'm not going to say set it to immutable because we want to make it changeable. And then the owner will always be whoever is deploying this contract. So the owner of this contract will be the one who deployed this, okay? Now let's implement the functions that are missing, which is the first function is a view function that returns the owner, okay? So let's create a function, owner, and its external view returns address. So it will return an address, and it's external, so anybody from outside this contract can call it. I think it should be public, actually, private, called public. I mean internal, sorry. It should be internal, so we could, sorry, it should be public, so we could call it from inside and from outside the contract. Okay. Even though I don't think we need it, but maybe we do. So we'll keep it public for now. Okay. And then we will just return the actual owner. All right. And the other function that we need to implement is transfer ownership here. Okay. And now to transfer ownership, we're going to do function transfer ownership, and then it takes an address and we call it new owner, and it's an external function that returns nothing, right? Yeah, as per the standard, it does not return anything. And in this case, we just set the owner to the new owner, okay? But we also want to make sure that this function here cannot be called by anyone except by the previous owner. So what we say here is require message.sender, like the whoever is calling this function is the actual owner. And then here, if it is not the owner, we just call it ownable. Caller is not the owner. All right. So now we have this, right? So now we have the ownable. So a better way, since we implemented this owner, this owner contract, and we know now if another contract is going to inherit the ownable, it's going to check if it is the owner calling, right? So what we can do is use modifiers, right? So these modifiers are a kind of a function that gets called before and after a function. So you define a modifier and then you add it to your function and it will be triggered before and after, okay? So to define a modifier, we use the word modifier, and in this case, I'm going to call it only owner, which means that only owner can call this can pass this modifier, right? And only owner, what does it check? Require. We require that the message.sender is the owner, okay? And if it isn't, we throw ownable caller is not the owner, right? And then we add an underscore like this, right? So what a modifier does is what is before this underscore is called before the function, and the statements that are after the underscore will be called after the function, okay? We will see other usage for it later on where we can use the before and after. But in this case, we only need the before. We want to check if the owner is the caller. So what we can do now is remove this require here, and we just add the actual modifier here and add it, and we say only owner. And that's it. Now, this function, whenever it's being called, it will call only owner first, okay? So now the implementation of our ownable contract is ready. What is not ready is the tests for it. So let's go and create the ownable test.js. Okay. I'm going to take the same boilerplate from the before, right? I'm going to take the same boilerplate so I don't have to type it, and then we're going to pass it here, and we call this one ownable. Sorry for the caps, ownable. And here it should deploy with the right owner, okay? And then let's close this one here. And let's close the other function. And this way we have a complete thing. So as before, we import the signers, and then we create a contract factory, ethers.create get for contract factory with the name of our contract, which is Ownable, right? And then we deploy the Ownable, and as you can see, the deploy here takes no arguments because our contract here does not take any arguments, okay? And this should deploy. So I'm not going to say with the right owner here, I'm going to say deploy correctly here. So if it deploys without throwing or reverting, then we're good to go for the deployment, okay? And then here it should set the right owner, and to set the right owner is the caller, and the caller is the owner here, right? So we expect the call to owner function to be equal to owner, right? And then the other test is should fail to transfer ownership by non-owner, right? So basically, if someone that is not the owner tries to call this this function to transfer ownership, he shouldn't be allowed to do so, okay? So await, expect, and then actually we're going to call this dot ownable, lowercase I think, ownable, this dot ownable dot transfer ownership. And before we call transfer ownership, we actually connect the non-admin, which is address 1 dot address, actually not. And we try to transfer ownership to ourselves even though we are not the owner, and we expect this one to revert with ownable, caller is not the owner, right? And then the last test is it should actually transfer ownership by the owner, right? So it should actually just, so, okay. So first it should transfer by the owner, and it should actually emit the event ownership transferred, right? And now that I think of it, I don't think when we transfer ownership, we ever did that, ever. Not in the constructor, not in the transfer ownership, right? So what I'm going to do is I'm going to call function, and then I say transfer ownership, and then address new owner, and it's a private function. So only this specific contract, not even the inheritors, can call it. And what it does is it sets the owner to the new owner, and it also emits ownership transferred with the old owner and the new owner. And because we overwritten, I think we should emit the event before the state change here. So we have them both. So the old owner is this one, the owner, and the new owner is this one, the new owner. So now we completed our transfer ownership, right? Previous owner, new owner. So now it emits the event. Let's go back to our test. So first we expect transfer ownership to address 1 to emit the transfer ownership with the right arguments. And the other thing that we expect is that the owner will be the new address 1 and not the owner, right? And with this, all our functionality is tested, right? So with the owner, everything, except there is one thing that is still missing, as we said before. Actually, we created this function, but we never used it. So let's run the tests and see how they fail. Let's run them and see how they test, how the tests run, will fail. As you can see, we fail. Fail should fail to transfer ownership by non-owner, right? So this one has failed, and it failed with invalid argument. Okay, so the invalid argument, I'm thinking we transfer ownership to a signer while we should use the address, because these here are not addresses, they are actual objects like Ether signers, and they have a field called address that holds their address. So in this case here, we actually did not access the field. And the second ownable to be emitted, but wasn't it. So we expected the event ownership transfer to be emitted, but it wasn't. And the reason why is we never actually emitted events, because transfer ownership here, we're setting the owner bit, we're never actually emitting the event. So we'll just call the internal, the private transfer ownership, and it will take care of the event. And we'll do the same in the constructor here with the same parameter transfer ownership, and we say message dot sender. Okay. And if you're wondering, transfer ownership here, because we never set the first owner in Solidity, the default value for these there is a default value, there is no null, right? So this one is not null. When we don't set it, it means it's the address 0. If you put like a uint there, it's not null. If we set uint and we never initiate it, it will be set to 0 and not null. So there is no null in here, in Solidity. It is a default value, okay? And these, you can look at them up in the Solidity documentation, like the boolean, the default is false, numbers are 0, addresses are the address 0, and so on. So the primitive types all have a default value, okay? Now let's run tests one more time to see if we actually fix our, and as you can see, the ownable is now passing, okay? So we created the ownable to solve a problem. As I told you before, when you're creating a project, it's not about creating the actual project, it's about solving problems, and we solve problem after problem after problem. So in this case, our problem is how do we stop everyone from calling the set minter? And how do we stop everyone from calling mint? How do we only allow a certain individual to call this function and no one else? And now, because we have the ownable, all we have to do is inherit it. And to inherit it, same as before, we are going to import it first. So we are going to import the ownable here, .sol, right? And then to inherit from multiple, you don't put another is, you all have to do is a comma and then the name of the contract you want to inherit from. So in this case, we want to add ownable, right? And now we have access to all what ownable has to offer, and what ownable has to offer is the modifier of only owner, right? So now the set minter here, I only want the owner to call it. So I will add only owner modifier here, and now no one can call this function but the owner, okay? So let's go ahead and take the function to the bottom here, and that's it. Now let's maybe create some documentations or like some comments for this function here. So this one adds a new minter, the parameter minter, the address of the new minter, right? And that's basically it. And the actual second parameter is minter. So the second parameter is minter if true, if the address is a minter, true to set the address as a minter, false otherwise. So basically, if you want to set someone as a minter, you send his address and true. If you want to remove someone from the minters, you send his address and false. Okay. I could have created add minter and remove minter, and maybe that's better because it's. I think maybe we go with that. Yeah, let's go with that. Let's go with that. So I'm gonna remove the boolean from here, and here minter. I'm gonna say to add, right? I'm going to rename this one here, minter to add, and then in the minter to add here, we're going to say true, okay? And then we're going to change the name here and call it add minter, and add another function that we're gonna call function remove minter, and it takes an address, minter to be removed, and it's an external, only the owner can call it, and it just set it to false, so this guy will no longer be a minter, right? And we are going to actually create some comments here. So now we have what we need. All right, so here we go. We remove the minter, we add the minter. Now, because we have them, we still did not fix the mint function here, right? So the mint function it can be called by anyone, right? And we don't want it to be called by anyone. So what we are going to do is we are actually going to make it only so that only the minters can call it, okay? And we can create a modifier, or in this case I don't think we need a modifier because the only one who's gonna use it is actually this function. We don't have to reuse it. If in the future, if in like later the usage, we find out that we have this check in so many functions, we just create a modifier for it, right? So now only a minter can call the mint function, okay? And it mints here. Okay, so basically all the functionality that is related to the minting is here, right? We need another functionality, which is burn. But before going to burn, I think I'm not comfortable to add more features to this project just yet, because there is like, think of it this way, right? I'm going to open Paint here, right? Think of a meter, right? We have a meter here, right? And I'm gonna call this one danger, right? So excuse the name in here. So here is a danger, right? And at the start here it's green, safe, right? So when you start creating a program or making your project, when you didn't write anything, your project is safe, right? Once you start making changes, it's still green, but at some point, right, it starts getting a little bit less green, right? So here it's gonna be maybe yellow, right? So here the danger will start, right? And then the more changes you add or more feature you introduce, the more less confident you will feel, right, in your code that it is working, right? And this is like, and the more you continue working, even though you feel that you are in the red, the more stressed you will feel, right? And sometimes it feels like if you start creating tests now, right? Oh, it's going to take a lot of time. I just want to have something working, and then I implement the tests and I do this and that. But in reality, that's called technology debt, right? So it's basically you're borrowing time from the future, right? And eventually it's gonna catch up to you, right? And it's gonna catch up in the bad time, right? And this happens a lot in like corporate and like in like more team oriented like places or like with a client that is pushing you for a deadline, and you should never do that. The technology debt is the first thing that will bite you, right? So in this case, like we don't have a lot of changes, but I'm trying to make you understand that the more you write, the more dangerous your code becomes, right? So what you do is the more you type, the more features you introduce, or the more code you write, you get into the danger. To reset the counter, you have to create a test for all the things that you have just implemented. And then you will reset it here because you are in a safe spot where you know your code works all over the board, right? So now you're in a state of mind where you're safe. You know your code is safe. You know your features are safe, right? And your project is in a usable state. And then on top of that usable state, you have like a clean slate where you can start creating new features. Okay, so this was a sideway. So now I'm going to create a file to actually test the Mintable token. So we're going to say Mintable .tests.js. Okay, and same as before, I'm going to copy the boilerplate just because I really don't want to like retype it. So here I'm going to say Mintable ERC20, and I'm going to say it should deploy correctly. I'm going to close this function and close the other function as well. And then here in the deploy part, we are going to deploy the Mintable ERC20. So to deploy it, same as before, we import our signers. We create a factory from our Mintable factory. Let me just close some files here because it's getting a little bit too much. Okay, beautiful. So I'm going to remove this one, and I'm going to remove this one. Only our file and this one. So we are going to deploy. And as you can see here, we need, when we deploy, we need a name, symbol, decimals, and initial supply, right? So I'm going to actually copy them from the simple ERC20 here. And I'm going to go back to my Mintable token here, and I'm going to name it Mintable and MTK Mintable token, right? And now we are deploying the Mintable token, which takes a name, a symbol, a decimal, and an initial supply. All right. We're not gonna run the tests about the name, or we could also write test the names about make the tests about the names. The rationale behind it is maybe when we implemented Mintable ERC20 token, when we're like relaying the constructor arguments, we actually messed up the order or changed stuff here. That's a viable option, as viable like rationale, but I don't think we made that mistake, and I don't think it's worth recreating all the tests for that specific case, right? And even if we do want to do that, I think the best course of action is to just come here, copy all the tests that we have done here. Even though I hate copy pasting like so copy pasting code here. So if we do this, and I'm going to come back here, I'm going to make a comment here saying simple ERC tests, and then I'm going to copy the actual like functions here and test the name, the symbol, the decimal, and the initial supply. I think those three are the ones that we should test, right? So I'm going to do that. I'm going to copy them. I hate this, but I think we should do it. So now, as you can see, it uses simple ERC20, while here we are calling it Mintable ERC20. So I'm going to change that name as well. And then we are going to call the tests by calling yarn test. And we have some issues. Value of the given number and big int inputs were compared. They were different. So we expected it to be equal to decimals, but it wasn't, right? So as you can see, we probably made a boo-boo somewhere. So let's go back to our function and see what we did wrong. So we need the name, the symbol, the decimals, and the initial supply to deploy, right? And we take the name, symbol, decimals, initial supply, and we pass them along the same order. Yeah, in the same order. Yet, somehow, we made a mistake. Somehow, when we are calling decimals, we expected 0 to equal 18. So let's see what we expected 0 to. So basically this call gave us 0. Let's see why is that. So we imported simple. Let's see simple. Balance of name. Do we have a decimal somewhere in here? We don't see it. Mutable public decimals. It should be here and it should be 18. So let's just log it. So we log this one and we log decimals. And we log console.log decimals. And here we say decimals. Still failing. Let's see our console logs. So the actual call to decimals is returning 0, which is very interesting. I can see why. Because we are passing the decimals, like the actual immutable states variable decimals, and not the actual decimals from the arguments here. And that's why it is messed up. So I guess it was a good idea to rerun the tests in this case. So yeah, we back here. Let's remove the console logs. And now we know that our implementation is actually, so these are the parts where it could fail, right? I brought these because we are relaying these these arguments from our constructor of the Mintable ERC to the constructor of the simple ERC. So we might mess up, or someone else can come along and mess up. So it's good to catch it now. Now let's test the Mintable functionalities, right? Beautiful. So I think we need one other thing here. The mint should be either a minter or the actual owner, right? Or owner equals the message sender. So either it's the owner calling this function, or the actual minter, the minters from the it is a minter, right? So here we will say it should fail to it should fail to mint from non-minter, right? Then we're gonna add async function. Then we're gonna import our signers, and then we're going to connect the address 1 and try to mint to the owner or to address 2. Actually, I'm gonna give them like human names: Alice and Bob and Carol and David. This way makes more sense. Since we don't need Carol and David for now, we're gonna keep Alice and Bob, and then Alice is the one that's going to connect, and she's gonna try to mint some free token to her friend Bob, right? But it should revert, right? We shouldn't do this. Okay. Let me remove this and close this. And it should reverse with this specific error message. So we're going to copy it and put it here to make sure this is what we have. So if I run the tests now, this test should still pass, right? Because it reverts. Now, owner should be a minter. Now it's weird because the owner is not a minter per se, but he is the owner. So if we call is an owner, I don't think we have a function to check if someone is an owner, which is another function that we have to create. Is minter, right? And then it takes an address, potential minter, and it's an external view function that returns a boolean, and it returns minters at the potential minter. And maybe if potential minter is the owner, we just say it's true, right? We just return true. I'm gonna remove the brackets here because it's a one-liner, so we don't really need to add them. This is better. So if it is the owner, we directly return true, and if it is not the owner, then we check if he's a minter or not. And you might be wondering, why don't we just make the owner minter by default, right? And that's possible, but then it's possible when we deploy, right? When we deploy, we can set the message sender to a minter. That's fine. Everything works out, right? But now imagine the ownership is transferred to someone else, and the transfer ownership is in the ownable, right? Right here. Now, if we transfer the ownership here, now what would happen if we transfer the ownership? I think that's better, you know, because we can't implement it here, but we could still do virtual here, right? And we can go ahead to our, so we're going to remove this one, right? And we are actually going to set the owner here, the minter as the message sender, the owner as an actual minter, right? And the other thing that we are going to implement is a function that is transfer ownership, right? And then the new owner, it takes the new owner, it's an address, and it's external, and it overrides the previous implementation of transfer ownership, and it adds on top of it to set the minter. It complains here because it's an external and we have to make it a public. Actually here, external, the one that we need to make it public is the one in public. Beautiful. And now we should be able to actually call it from here and change it. overriding functional variability differs. So we have to actually set it as public as well. And with this, it means we are calling the other function, right? Another better way to do it is to actually make this one internal, keep this one external, and go back here and do it external and make this one back external. And then here, we're not going to call this super one. We are actually going to just call the transfer ownership, the internal one, and actually remove the old owner from the minters, set the new owner as a minter, and then we transfer ownership, and now everything is back to order, right? So now the owner should be a minter, and when we change ownership, it changed also with the beauties of inheritance here and some overriding. We managed to do that because now when the Mintable ERC20 is called and the function transfer ownership is called on it, it will change the minters. Is minter, it returns the minter, so now we no longer need to check. Transfer ownership, only owner can call, that's fine. And this is beautiful, nice. So what we need next is to continue with the test. We said the owner should be a miner. I think the owner should be a miner. A minter, sorry. I think this would be an asynchronous function. And we should use this kind of function, so we can use this. And now we import our signers, and then we check if the owner is a minter, and it should return true. Okay. And then we should check if a minter can actually mint. So a minter, which is the owner, if the owner call mint and he mints to, I think he should mint to Alice here, Alice, and we mint 1 token. Like, actually 1 token is 1n times 10 to the power to the decimals, and we expect the balance of Bob to be of Alice to be 1 token, right? And I think I'm going to also expect the mint to actually expect dot to emit. It should emit the transfer from the address 0 to the Alice for 1 token. So that's what we should expect. We also, we also expect the total supply to be more than the initial supply, right? So we expect the total supply to be the initial supply plus the new minted value, right? Because we minted, we expect the total supply to go bigger. So let's run the tests here. And this is the test that I told you about that should be failing, right? Because our mint function actually never touches the total supply. So now, as you can see, we're expecting the total supply, which is 0, to be equal to this number right here, right? To 1,000,001. So what went wrong? Let's go back here. We're calling mint. Let's go to the mint definition, and we're minting. We're making the transfer event, but we're never touching the total supply. So what we should do here is actually add to the total supply, okay? So once we do that, I think we can save some gas here if we do this. So we add the total supply outside of the check, and then in the end checked, we increase the balance. The reason for this is if the total supply overflows, then it will reverse, right? But if the total supply did not overflow, there is no way for the balance at 2 to overflow. Get it? Because the total supply will always be either equal to the balance of 2 or bigger than it, right? So if it didn't overflow, no way the balance can overflow. So we can save a few gas here by going on the end checked. So we don't need to check for the overflow here. Same goes for if they try to send a negative number or something similar, the total supply will overflow. Okay. Let's continue now with, and that's why I use the end checked here, because the checks are already done here, so we don't have to do the checks again. Now let's rerun the tests, and now all our tests in the Mintable should pass, but the tests on the other side should not. But apparently they did not pass either. So the total supply plus the value and the balance is plus the value, right? Okay, so why is it failing? Still failing. So the first one here, I think I know why it is failing here. So the total supply here is still failing because we're expecting it to be 0, but it should be actually initial supply, right? And the second part where it fails, I think it's the same issue. We're expecting it to be 0 while we should expect it to be the initial supply. Now we rerun the tests and they pass. Okay, beautiful. So we have the minter, so non-minter fails, minter can mint, and it emits the events and everything, right? So let's say the other test that we should test is should fail to add a minter by non-owner, right? So only the owner is should be allowed to call the add minter, right? So if Alice tries to add herself to the minters, it should reverse. The transaction should reverse, right? And the same goes if it should allow owner to add a minter, right? So if the owner is calling the add minter, he should be allowed to add a minter. So if he wants to add Alice to the minters, Alice should become a minter, right? So let's go ahead here, and I think there's one third or 2 more tests that we should. It should fail to remove a minter by non-owner, right? So basically, if Alice tries to remove herself from the minters, she can't. But for a better test case, let's have Bob try to remove Alice from the minter, right? So Bob got jealous of Alice, and now he wants to remove her from the minters. So he's trying to call remove minter to remove Alice from the minter, and it should fail with ownable caller is not the owner. Now, on the other hand, if the owner got sick of Alice minting tokens, he should be allowed to do so because he's the owner. He's running the contract in God mode, so he has all the rights. So let's import the actual signers here, owner, Alice and Bob, and we call the remove, so we're removing Alice, and we expect Alice to no longer be a minter, right? Now let's run these tests, and they all pass. Beautiful. The other thing is we're not just implementing the burn or the mint, we actually need the burn as well. So what we do now is we're going to go back to our Mintable token and actually implement the burn, right? And for that, I'm going to create the burn mechanism here. And we are going to create a function. We call it burn. And we can actually remove override, remove virtual, leave it internal. And then I don't think we should be a minter. Anyone can burn, right? If a user want to burn his own tokens, he should be allowed to do so, right? But now here, what we should be allowed to do is burn. Actually, let's remove the account and only burn an amount, right? And we actually just want to change the balance of this person, right? So let's try to access balances, right? Balances at message sender, and we reduce the amounts. And as you can see, it complains. Why is it complaining? Because balances, if you remember, I told you I wanted to make it private. So a contract that inherits cannot manipulate the balances, because the balances needs to be like following like accounting principles, right? So to debit from an account, to credit an account, you have to debit another one, right? Unless we're minting, then we are minting out of thin air. But if we are actually burning or minting, or if we are like transferring, we have to debit an account and credit the other account, right? So it's what they call dual entry ledger. But in our case here, we cannot access the balances here. So what we should do is we go back to the simple ERC20, because the simple ERC20 is the one supposed to actually manage those balances and have the lower level calls to actually manage these. So we are going to take the burn function here, and we are going to burn the tokens, right? So we burn from the message sender, and only from the message sender. Or we could also, if we want to have more functionality or more possibilities, we can say address user and an amount, and the user's balance, the balance of this user should be, and then should be reduced by the amount. And also the total supply should be reduced by the amount. And we should also emit an event that we transferred from this user to the address 0 this amount, which is what should happen here, because this is what should happen, because we transferred from this user's balance to the address 0, which is the equivalent of burning, okay? So let's go back to our Mintable now. And let's create a normal external function called function burn, right? And then the amount external, and it just burned that amount from the sender's wallet, right? And you might be wondering here, why didn't we check if he has the balance for this, right? And you're right. This is not dangerous, because if this one underflow, the checks of solidity will trigger the reverse, right? But we want a more we want to throw an error that the user can understand, right? So what we are going to say, require, right, the balance of this user to be bigger or equal to the amount. And then here we just run the end check, and because we already checked, there's no way for either of these to enter flow, right? Because the total supply will be always equal or bigger than the balance of this user, and we know that the amount is bigger or equal to this one. So there is no way in hell this arithmetic operation here underflows. So we remove the checks to save some gas, okay? Because we already checked it here. So now we don't need the checks anymore. So we're gonna call unchecked and then make our arithmetic operations. We emit the event, and now we have our burn function. So let's go back to our Mintable, and let's make Alice burn her own token. It should allow Alice to burn her tokens, right? And this is an asynchronous function. All right, now we import the signers, and then Alice is going to burn her tokens, right? And now what we expect, I think something is missing here. We expect this function call to emit the transfer event that Alice sent the amount to address 0, right? And we also expect the balance of Alice to become 0 because she burned her tokens, and we also expect the total supply to be back to the total supply because we minted for Alice and now we burned it, so now we're back to the initial supply, right? So let's run the tests, see if everything works. Something is not right. What did we expect and what we got? We expected this address to be equal to this address. Now, I think I know what happened here, because we called burn, right? But we never connected Alice to this contract. So let's connect Alice actually here and make the call. So now let's rerun the tests. They should be passing. Yeah, 32 passing, 0 fail. I'm going to format my code. So to recap, our tests are here, and I think I'm going to show you one last thing here. And the other thing that I want to talk about now is the Hardhat coverage function. And what coverage function does is it checks your tests against your contracts, and then it gives you how much you're covering in your code. So if there is like some certain parts of your code that you're never running, that your test never got into it will show you those parts, right? And it will tell you that your coverage is 90% or 91%. And what this is, why this is very helpful, it's because maybe you have so many functionality and you forget to test some of them, right? But with this, with the coverage, you can like be sure that you are actually covering most of your contracts. Okay, so let's call npx hardhat coverage, and now it should run our tests, right? It should compile our contracts and run our tests, and then it will give us like how much are we covering, right? And as you can see here, it tells us that we are covering like 69% of our statements and functions and things, except here in our Mintable here, it says we are only covering 80% and 70%. And it even gives us the lines that are uncovered. So let's go to the Mintable here and check the line 52. What is 52 here? Okay, as you can see. And the line 52 is the transfer ownership, right? So we never actually call transfer ownership on Mintable, right? And now it's telling us that these 3 lines right here are never tested, right? So, and it doesn't just give you this. You can have, if you go here, you can find a folder named coverage. I'm going to open it in Explorer. And it's basically like a website, right? An HTML page that you can open, and it will actually give you visual things, right? So I'll click here, 80% only. I'm going to click on Mintable, and it should show me the places where something is not covered, for example, right? So for example, this one here, this is in all my tests, this one never executed. And do you know why? Because it never reaches this part, because we changed the way the minters work, and the owner is always a minter. So it's always checking this one, but never reaching to check this one. This is an OR. So if this one is true, it doesn't have to check this one, right? So we can just save some space on our contracts by just removing this one. And that's what I'm going to do right now. And you can see, and you can already see how the coverage function helps us a lot. So here I'm going to remove this one, because this one will never trigger, right? Because the owner, whenever we're changing it, we're setting it to an actual minter. So we don't really need that check. So that's one check. And the other one is this function is never being called, because we never created a test for it. So what we're going to do is we are actually going to go to the Mintable tests, and we should test it. The first thing that we should fail, well, actually, maybe we need one more test, probably. Because if I go to the ERC, it says 100%, but I don't think it is 100%. There are places where it never reached here. For example, here it says this path was never taken, right? So basically it's never failed this one. So we don't have a test that's actually test this require function here. And as you can see, the E here tells us that. And you can see it outside here. That's simple. All the statements are tested, but the branches, only 80% of the branches are tested. So there is some conditions that we never tested, right? And in this case, the condition that we never tested. All right, we're here. That was a phone call. Sorry about that. Okay, we said this branch is never executed because we never actually tested if we never tried to burn more than our balance, and that's what we are going to do here. We are going to do it before Alice here. It should, we're going to say it should fail to burn more than the balance, right? Async function let's import our signers. Let's import our signers, and then let's try to burn from Alice. So let's connect Alice, and we try to burn 1 plus her balance, right? So now if it should be more than the balance. Let's see the error that we actually throw. Burn amount exceeds balance. So let's go back here and set to the right one. And now let's rerun our coverage. And it should now have, well, let's see. Simple. There are new branches that we never tested apparently, or something similar. So let's go ahead and see if this branch actually went through. And you can see now we went through it. And the other thing here that is saying else path. So we never tested the transfer with insufficient balance, and we never tested, this is on the simple ERC20, we never tested sending to the 0 address, but we actually did. So I don't think that is true. Transfer from, I think this is just a bug. Let's rerun the coverage, see. All right. I still think these are bugs here, but we'll continue with the mint. So the mintable, we said 52, 53, 54. That should be the owner, right? So it should fail to transfer ownership by non-owner. Okay. And we are going to call it async function. I think this test is redundant. If we actually made it better, we can actually make it better. We remove the only owner from here, right? We're going to go to the ownable. We were going to remove only owner from the external functions, and we are going to add it to the internal function, right? And since everyone rely on this one to change, only the owner can call it, right? So if whoever is calling is not the owner, good luck changing it, right? And this should actually, I'm just going to run the tests here. I'm going to run yarn test, and our test should be passing. Well, something happened because I think when we were creating this, so let's try again. I think there is an issue and I know what it is. So let me go back to our ownable here. And because in here, if we are trying to transfer ownership, actually the message sender is still not right. So what we are going to do is the message sender is the owner, or owner. Actually, we can't do this. Now we cannot do this. Because if we set it to if the owner is still address 0, then it doesn't make sense. So we're gonna set it actually here, the message sender, and we're going to emit the event manually here, because this is safer, right? Why is it safer? Because now any inheritor who transfer ownership has to be the owner, right? So you cannot transfer ownership if you're not the owner. All right, let's rerun the tests. It should be passing now. All of them, beautiful. Now let's go back to the Mintable here and test the ownership. We don't have, sorry. So we don't actually have to test the change of the ownable by non-owner, because we actually never touch it that, and we cannot touch it ever because we're calling this one, and that's the one that is responsible for the owner. So that this is better design. And here I'm going to say it should remove old owner from minters and set the new owner as minter, right? And we're going to create a function here. A function we're going to import our signers, and we are going to transfer ownership to Bob by the owner. And now the owner should not be a minter. Is minter should return false, and Bob should become a minter. If we want to add the extra check, expect the owner to be Bob, I think we should add it, because there are ways for us to screw this one up. Because if for some reason I'm working here and then someone comes here and be like this, then that test will fail, right? For now, we'll run this test and it passes. So if someone comes here and removes this, or maybe does something like message.sender here, or make mistake here, right? Let's say he makes this mistake. He calls it the message sender. And our last test should fail because it shouldn't. It should be this one, right? And that's why I added that expect there, because it's actually something that we can actually do wrong, do wrong. Okay, beautiful. Now let's run npx coverage. I'm actually going to add it to the package here, to the scripts. Coverage, and it should be Hardhat coverage. So now all we have to do is yarn coverage and wait. And as you can see now, we have better coverage across the board. There are a few Mintable. There is 10 branches in simple contract that are not being executed. So let's go there and actually check where these branches are. And the branches will be something where the E is, right? And that is the only check that we are not checking is when someone allows the maximum allowance, and when someone has allowed someone else to use the max int, uint, and the allowee or the spender is spending. So that's test we never wrote. So we're gonna go back to our simple ERC20, and we go into it should never reduce allowance when allowance is max uint 256, right? And a sync function. So we are going to actually import our signers owner, and let's get Alice and Bob. Just Alice. Let's just get Alice, and then we get it from the signers, and we go into approve. So the owner is going to approve Alice to spend the max, right? And then Alice is going to transfer from the owner, and it's going to transfer, let's say, 1 times 10 power decimals, right? And after that, we expect the allowance to still be the max int, right? So let's do this. Sorry, I think I'm going to stop this. Let's run yarn test. All tests are passing. Now let's rerun the coverage. And as you can see now, we have 100% coverage of our code. All branches, all functions, all lines. Our tests run through all the lines and pass through all the lines in our code. So there is no side case, no condition, no nothing that happens in our code that we don't cover in our tests. And this is nice. This is beautiful. So let's go back here. If we refresh, this one will disappear. Some of them have more calls than others, right? But that's just because we inherit from it. But now if we go back to our to our graph here, we are definitely in here in the safe area. We have all our code in front of us. It's all tested. No side case, no condition that we did not test. So let's just format the code and commit it. Beautiful. Now, so on this one, we covered coverage. Maybe in the next video, I'm going to add Husky and show you how to make it so when you are committing, you actually check if your tests are passing, and if a test is not passing, it will not let you commit. Okay. We're going to add to git ignore here. We're going to ignore coverage.json, and we are going to ignore coverage, the folder, right? So both this one and this file, because they shouldn't be in the source control. Git status, let's check. So git ignore changed, simple ERC changed, the package.json changed, the test, the simple ERC20 changed, the Mintable ERC20 changed, we created it, the Ownable we created it, the interface folder we create, and the 2 new tests. So these are the files that we are going to commit, and they all, this looks okay, so let's format, beautiful, and then let's just add to the source control, and then let's commit, add mintable vulnerable token, or let's call it ERC20. I think we forgot to add Kitty. And then git push. And it should put to source control to our GitHub. Let's go back to our document, and we actually finished the mint burn token. Text underscore strike through. So in the next video, we are going to create the liquidity generator token, and then the dividend token. Or maybe in the next video, we start making creating the front end and actually creating the pages related to the simple ERC20 and the burn token. It's definitely a possibility, but I think we'll continue with the ERC20 implementations and then go to the front. I always like to finish my contracts before going to the front end. All right, I think this is it for this video. I'll catch you guys in the next one. Have a good day.